Okay, so we'll look at dividing decimals today. And the first few examples that we're going to do is to do with the decimal number divided by a whole number. All right, so let's start off by writing that out. So 1.22 divided by 3. So 3 goes into 1. No, we've put a 0. And bring the next digit, which is 2, and make that a 12. So if I put these two digits together, it gives us a 12. But between the 1 and the 2, there's a decimal point. Okay, so the rule is when we are dividing decimal numbers, that in your answer, your decimal point in your answer and your decimal point in your question, they need to be lined up. So I'll do a little arrow over here to show that. So these two needs to be lined up. What that means is lining up doesn't mean that you just put it anywhere as long as it's in the same line. It also means that it has to be in the same line in terms of your place value. So if you have a look at the question in 1.22, the decimal point is between the ones and the tenths place value. So in your answer also, the decimal point has to be between the ones and the tenth place value. We'll look at when you look at the final answer, you'll see that that's where it is. All right, let's keep going. Now, when we combine the two digits 1 and 2 and ask ourselves, can 3 go into 12? Yes, it goes 4 times with no remainder. But then we still have one digit left, 2. Can 3 go into 2? No. So whenever it cannot go, we'll add a 0 over there, put a 0 in your answer, but at the same time, because we already have a decimal point, we add a 0 to 2 to make it 20. 3 goes into 20 6 times, and what's remaining is 2. Put a 2. Again, 3 can't go into 2. We've got a decimal point there, so we add a 0. 3 goes into this 20 6 times. And if we notice, there's a pattern. Every time, you'll get a remainder 2, and it'll always go into 26 times. And because the number 6 keeps occurring, we call this a recurring decimal. Okay, so recurring decimal, to show that, the way we show a recurring decimal, I've got a little note over here, is you either put a little dot or an apostrophe on top of the number that keeps occurring. So we'll put a little dot on top of 6 to show that it keeps occurring. So the answer to this becomes 0.4066 recurring. Okay, let's have a look at the second example. Same deal. We write down 18.46 divided by 7. Same process. The process doesn't change. 7 doesn't go into 1, but 7 goes into 18. Now for this one, we don't put a 0 in your answer right now because we still have digits that can make it into a whole number for which we can ask if 7 can be divided by. So 7 2s are 14. Okay, the maximum number of time it goes. 2 times 7 is 14. What's remaining is the 4. Let's take the 4 next to the next digit, and that becomes 44. Okay, but before that, if you notice, our decimal pointers over here, as I said, it needs to be lined up in your answer as well. So we put a decimal point there. 7 goes into 44. How many times? Ask ourselves. 7 times 7 is 49. So no. Let's go 1 down. 7 times 6 is 42. So out of 44, 2 is remaining. Goes next to the next digit, which makes it 26. Okay, 7 4s are 28. So we go 1 down. 7 3s are 21. 21, and there's 5 remaining. Again, we do not have 5 is not big enough for 7 to go into, so therefore we've got a 0 over there, add a 0. Sorry, we've got a decimal point, add a 0. 7 into 50 goes 7 times, and now there's a remainder 1, and this can keep going on and on and on. But if you notice, they're different digits that keep going on. So they're not the same digits. Like in the first example, we had the same digits repeating. But this is where there are different digits repeating. Okay? So when the different digits are repeating, firstly, let's just write down the answer first. If this is 0, 7 into 10 goes once. After that, there's a remainder 3, and the sentences keep going on and on. So we stop. How do we know when to stop? Okay, so we know when to stop. We can either stop after 2 decimal places or 3 decimal places. I'm going to go up to only 3 decimal places, and I'll write down approximately, so you can say equal to, which is 2.637. If it's not exact, because it's not exact, one of the ways to show that is by using squiggly lines or an equal line with the dot. But we'll learn more about that when we do a higher maths. Now, if you have a look, these digits, they don't have a particular order, okay? So therefore, they are non-recurring. We don't have to know this right now, but it's good to know so that we can identify. Because in the previous example, you can see that 6 kept repeating. Sometimes we have the same 2 digits repeating. It could be 2.636363. They are recurring as well. But for this one, because they don't have a particular order, they are called non-recurring decimals.